Alright, this is your Unit 10 review video on trigonometry for Algebra 2. I'm just going to start on your I need to memorize page because these are really the big things that you need to know in order to do trigonometry. The first thing is your exact value chart, where you should really memorize these values, but the chart can be generated really quickly by just writing 30, 45, 60, sine, cosine, tangent. And the saying goes 1, 2, 3, 3, 2, 1, all over 2, and square roots of the tops. Which is actually the little saying that I wrote at the bottom of the cover sheet. 1, 2, 3, 3, 2, 1, all over 2, square roots of the tops. So that gives you at least sine and cosine of 30, 45, and 60 in that order. In order to get tangent, that's sine divided by cosine, which I'll actually write this over here just so that we remember that that's something that you need to know. Or just memorize this. This is radical 3 over 3, 1, and radical 3. The unit circle is used for angles that are increments of 90. So 0, 90, 180, 270, and all the way back around at 360. So the unit circle has a radius of 1. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1 are your coordinates on the unit circle. So let's say, for example, I want the cosine of 90, or cosine of 0, excuse me. Cosine of 0 is your x-coordinate. So cosine of 0 is 1. Sine of 0 is 0 because it corresponds to the y-coordinate of 0 degrees. So every point on the unit circle is a cosine and a sine. So just to give you a couple more examples, if I want the sine of 90, go to 90 degrees, look at the y-coordinate, that's 1. Cosine of 270, I'm looking at the x-coordinate at 270, that's 0. Cosine of 180, go to 180, look at the x value, that's negative 1, and so forth. So that's how you use the unit circle. Other things you need to know, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Know your reciprocal trig functions. Cosecant is 1 over sine of theta. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta. Or, if you think about it in terms of sine and cosine, it's cosine of theta over sine of theta. In order to determine the arc length, you're going to use S equals R theta, or some people say S equals theta R for SOR. Either one is fine, but you need to know that S is your arc length. Theta is your angle in radians. That's really, really important. Otherwise, you'll get your answer wrong. And R stands for radius. Okay, so while we're speaking of radians, if you want to take a degree and convert it to radians, you take the degree and multiply by pi over 180. So for example, 30 degrees multiplied by pi over 180, 30 over 180 is the same thing as 1/6. So pi over 6 is 30 degrees. So pi over 6 is pi over 6 radians. If you want to convert radians to degrees, then you take the radian and you multiply by 180 over pi. So it's the reciprocal of pi over 180. It's like undoing it. Another thing you can do is sub in. That's supposed to be 2 words. Sub in 180 degrees for pi when you can. So for example, 2 pi is the same thing as 360 because it's 2 times 180. You also need to know your ASTC chart. All students take classes. All your trig functions are positive in the first quadrant. Only sine is positive in the second. Only tangent's positive in the third. And only cosine is positive in the fourth. So going back to the radian idea, remember that by definition, a radian is taking the radius of a circle and wrapping it around the circle. So again, it's the radius wrapped around. That is 1 radian. Reference angles. We always compare these to the x-axis. So every reference angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4 looks like a bow tie. If that's a good visual that helps you think about it, maybe a striped bow tie. We use our QRS method to figure out exact values of angles. Q stands for quadrant, R stands for reference angle, and S stands for sign, as in SIGN, so positive or negative. And then lastly, we have cofunctions. These are equal when their angle measures are complementary, which means they add to 90. So examples, sine and cosine. So like sine of 30 is equal to cosine of 60. You should have noticed that. They both equal 1/2 in your exact value table. Tangent and cotangent, and secant and cosecant, which I'll just write it as C as C. Okay, so you guys need to memorize everything. Now, I didn't fill in every little bit here, but you have the answer key online. You need to make sure you know all of the stuff to do well on your test. So study, study, study. Okay, so moving forward, I have some problems that we're going to go through. So I'll show you which ones. So starting at the first example, if sine of theta times tangent of theta is greater than 0, then theta must be an angle in quadrants. Okay, so we have a multiple choice. First, think about your possibilities here. If sine of theta times tangent of theta is greater than 0, which means it's positive, either both sine and tangent are positive, because a positive times a positive gives you a positive, or they're both negative. Oops. Okay, so again, a positive times a positive gives you a positive, and a negative times a negative gives you a positive. So think about it that way. So let's look at our first option, we'll say. I'll do this in pink. So if you look at your ASTC chart, sine and tangent are both positive in the first quadrant. Okay, so that's quadrant 1. Only sine is positive in the second, and only tangent is positive in the third, but you have to have both of them be positive. Now, if you want both of them to be negative, well, like I said, sine is positive in the second quadrant, tangent is positive in the third quadrant, but if you look at quadrant 4, in quadrant 4, both sine and tangent are going to be negative. So again, this is where they're both positive, this is where they're both negative. Therefore, your answers are quadrants 1 and 4. So option C. All right, so find the value, or the value of sine of pi over 2 is equal to the value of blank. Well, let's convert this to degrees. Pi over 2 is the same thing as 180 over 2. So that's sine of 90. Now, if you look at your options, I automatically know cosine of 0 is going to be the answer because sine and cosine are cofunctions, and they have equal values when their angles sum to 90 degrees. 0 plus 90 is 90 degrees. Therefore, those two values are going to be the same. And that's my explanation at part B. All right, the coordinates of a point on the unit circle, that's important, are negative radical 3 over 2 and 1/2. If the terminal side of the angle in standard position passes through the given point, find the measure of theta. Okay, so first of all, just think about where this point would be. If you were to plot it, you'd go a negative x distance and then a positive y distance. So you have to imagine this is on your unit circle, which any point on the unit circle is equal to the cosine of the angle and the sine of the angle. Okay, so let's find this reference angle. Sine of some angle gives you 1/2. Well, sine of 30 is going to give you 1/2. So this tells me that my reference angle, which is the acute angle formed with the x-axis, is 30 degrees. So this angle, which would then terminate right here at that point, must be 180, take away 30, so 150 degrees. Now, if you look at your options, None of them are those choices. So I have to convert this to radians. So I'm going to take 150 degrees and multiply by pi over 180. Okay, and if you're not great with simplifying, good thing you got your calculator. So I'm going to do 150 divided by 180 and do a math frac. 5 over 6. So this is the same thing as 5 pi over 6. And if you look at your choices, there it is at option B. All right, so points A and B are points on the unit circle. If the measure of angle AOB is theta, find basically all the trig functions. And we're going to put it in simplest fraction form. Okay, so they're just basically saying that this is the point A, and the point B is somewhere, because it was a negative negative, somewhere over here. They just say, like, if this is the measure of the angle, what's the sine, cosine, and tangent of that? Well, all you really need to know is that this is on the unit circle. So cosine of the angle is going to be negative 0.6, and sine of the angle is going to be negative 0.8. So this is negative 8 divided by 10, or if you want to simplify that, because it wants you to, negative 4 over 5. Cosine of the angle is going to be negative 6/10 or negative 3/5. And then lastly, tangent of theta is always equal to sine divided by cosine. So I can do negative 4/5 times negative 5/3. 5s would cancel, and I get positive 4/3. So then if I want the cosecant, secant, and cotangent of these angles, that's just the reciprocal of sine, cosine, and tangent. So for cosecant, I'm just going to flip the numerator and denominator and get negative 5/4. Secant is the reciprocal of cosine, so negative 5/3. And lastly, cotangent is the reciprocal of tangent, so positive 3/4. Now, one quick thing. Notice how only tangent is positive, tangent and cotangent are positive in our answers here. That's because the angle terminated in the third quadrant. So that makes sense. All right, so now we're going to use our QRS method. I want the cosecant of 60 degrees. Okay, so 60 degrees is in your first quadrant. So your reference angle is 60. So anytime it's in quadrant 1, that's kind of nice. Next, think of cosecant as the reciprocal of cosine, or excuse me, the reciprocal of sine. So let's first find the sine of 60, and then I can just flip it. Well, sine of 60 is radical 3 over 2. If I flip it, that will give me the cosecant of 60. So 2 over radical 3. We know we can't leave it like that. I'm going to rationalize the denominator. So I get 2 radical 3 over 3, and since we're in the first quadrant, everything's positive, so that's our answer. Okay, 330 terminates in quadrant 4 with a reference angle of 30 degrees. I always think about that as my distance from 330 to 360. So 360 take away 30, or take away 330 would give me my reference angle of 30. So I'm going to rewrite this as tangent of 30. All students take classes. Only cosine is positive in the fourth quadrant. Therefore, I need to add a negative in front of my tangent of 30. Okay, the tangent of 30 is radical 3 over 3. So this is negative radical 3 over 3. All right, secant of 13 pi over 4. Let's convert that to degrees first. 13 pi over 4 means I'm going to plug in 180 for pi. And I get 585. Okay, and that's a really big number. So let's find a coterminal angle by subtracting 360 degrees. So 225. Using the QRS method, 225 is located in quadrant 3, and its reference angle is 45 degrees. Which, I mean, it makes sense. This ends in 5. The only reference angle that also ends in 5 is 45 degrees, because your other options are 30 and 60. And 45 is this distance from the x-axis. So I'm going to think about this as secant of 45 and really take it a step further and think, all right, what's the cosine of 45? And then I'll just take the reciprocal of it, because that's what secant is, the reciprocal of cosine. All right, so all students take classes. Cosine is negative in the third quadrant, so let's think about this as negative cosine of 45. So this is negative radical 2 over 2. And then I have to flip it to get secant. So I'm going to do negative 2 over radical 2 and then rationalize. So negative 2 radical 2 all over 2, which kind of squeeze it in here. That's just negative radical 2. All right, converting to the nearest minute. If you have 13 radians and you want to convert it to the nearest minute, minute is degrees. So I'll take 13 radians and multiply that by 180 over pi. Now in your calculator, you're going to type in what is DMS, degrees, minutes, seconds. And you also have to make sure that your calculator is in degree mode, which let me double check here. I am, so we're good to go. So 13 times 180 divided by pi. And then I'll do a second apps, option 4, that's DMS, and I'll hit enter. So I have 744 degrees, 50 minutes, and 42.481 seconds. So to the nearest minute, because this is 42 seconds, that's over half of a minute. Half of a minute is 30 seconds. So since this is greater than 30, I'm going to round this up to the next minute, which is 51 minutes. So 744.51. All right, express each as a function of a positive acute angle. That just means a reference angle. If the angle is given in degrees, state your answer in radians. If it's given in radians, state your answer in degrees. Okay, so first of all, 280 degrees. Let's find the reference angle. 280 is going to be right over here. So your reference angle is going to be formed with the x-axis, so that's the distance from 360. So 80 degrees. So cosecant is the reciprocal of sine. So if all students take classes, sine is negative in the fourth quadrant. So I'm going to think about this as negative cosecant of 80 degrees. Okay, so again, one more time here. Cosecant is the reciprocal of sine. So that means if sine is negative in the fourth quadrant, cosecant is also going to be negative in the fourth quadrant. Okay, so I found the reference angle of 80 degrees because that's its distance from the 30 or 360 degrees. So negative cosecant of 80 is going to be the angle given in the correct acute form. Now, the only thing is it tells me to convert this to radians now. So I'm going to take 80 and multiply by pi over 180 and then just simplify. So 80 divided by 180, if I do a quick math frac here, is 4 over 9. So I'm going to write this as cosecant of 4 pi over 9 as my final answer. In a circle whose radius measures 4 centimeters, a central angle intercepts an arc length of 10. So they're telling you S, they told you R. Find the measure of the central angle to the nearest degree. So if S equals R theta, They told you S was 10, and they told you R was 4. So I'll divide by 4. Theta is equal to 10 divided by 4, which 10 divided by 4 is 2.5. But this is radians. So you need to convert it to degrees. So I'll take 2.5 and multiply by 180 over pi. And to the nearest degree is 143 degrees. All right, find the exact value of h of 280. They're just saying plug 280 in for x. Okay, so 3 times 280 divided by 4 is 210. And then this is where you use your QRS method. 210 is over here in quadrant 3. Your reference angle is 30 degrees because that's the difference between 210 and 180. So I'll rewrite this as cosine of 30 degrees. All students take classes. Cosine is negative in the third quadrant because only tangent is positive there. Cosine of 30 is radical 3 over 2, so this is negative radical 3 over 2. Find all options for theta such that the angle is between 0 and 360. Okay, so sine of some angle gives you radical 2 over 2. That angle is 45 degrees. Now the negative is telling you the location of this reference angle. Okay, so I'll actually rewrite this as a reference angle. Now if you think of all students take classes, sine is positive in the first and second quadrant, so those are out. That means your angle must be in quadrant 3 or quadrant 4. So let's draw our two possibilities. Okay, so your first one starts on the initial side, and then wraps all the way around. And like I was saying, your reference angle is 45 degrees. So you're going 180, and then you're adding an additional 45. 180 plus 45 is 225. So your first angle possibility is 225. Your second angle, again starting on the initial side, wraps all the way around. The reference angle is still 45, so you're going to think 360, take away 45, and that'll give you your reference, or give you your whole angle. So 315. So those are your two possibilities. Now here's how this works again. Just to show you, radical 2, radical 2 over 2 is this 0.707 number. If you were to plug in sine of 225, you would get that number, but just negative. So that's negative radical 2 over 2. If you were to plug in sine of 315, you will also get radical 2 over 2. But let's just say, for example, you were in the wrong quadrant. What if you just said 45 degrees? Sine of 45 is going to give you positive radical 2 over 2. Same thing for if you were in quadrant 2 and you typed in that angle. So because the angle has to be negative, or because our value has to be negative, well, that didn't sound too good. 1 second. No worries. I made cupcakes the other day, and my muffin tin just completely fell off the counter, so that's great. All right, so anyway. So yeah, pretty much you just have to make sure you're in the right quadrant in order to account for the value being negative, is what I was getting at. Cool. All right, so next is finding the exact value. So let's just plug in the stuff that we know. Tangent of 60 is radical 3. Tangent of 45 is 1. Cosine of 30 is radical 3 over 2. And sine of 45 is radical 2 over 2. All right, so I'm just going to clean this up a little bit. Let's write this as fractions. This is radical 3 minus 1 all over 1 divided by radical 3 plus radical 2 all over 2. So if you're dividing fractions, we're going to use keep, change, flip. So radical 3 minus 1 all over 1 times 2 over radical 3 plus radical 2. And just make sure you distribute the 2. So 2 radical 3 minus 2 all over radical 3 plus radical 2. All right, so this so far we have gotten to a pretty good point. We just have to make sure we rationalize. So I'm going to multiply the top and the bottom by radical 3 minus radical 2. Okay, so let's see. I've got 2 times 3, because radical 3 times radical 3 is 3. Then minus 2 radical 6 minus 2 radical 3 plus 2 radical 2. All over, now in your denominator, because they're conjugates, you can just do the first and the last. 3 minus 2. So that's kind of nice. So your denominator just goes to 1. Beautiful. So let's just clean this up. 2 times 3 is 6. And not much else you can do there. All your radicands are different, so you can't combine those. So that's actually your simplest form. Woo! All right, for 19, point H is on a circle with a radius of 5. An angle in standard position has a point H on its terminal side, and the angle measure pi over 4 radians. What are the coordinates of H in simplest radical form? Okay, so big idea here is that this isn't a unit circle, it's a circle with a radius of 5. But it is still going to be centered at the origin. Okay, because it's in standard position. So pi over 4 is the same thing as 45 degrees. Okay, let's first think of the unit circle. Like, where would the point be on the unit circle? And then what we can do is dilate by a scale factor of 5. So throw in some geo terms at you guys. And then that'll give us the coordinate point. So again, let's pretend this is a radius of 1. We know every point on the unit circle has the coordinates cosine of the angle, sine of the angle. So if this is 45 degrees, cos of 45, sine of 45. Okay, so this means our coordinate point must be radical 2 over 2, radical 2 over 2. All right, so that's, again, on the unit circle. We want to make this a radius of 5, so we're going to dilate it by a scale factor of 5, which means I'm going to multiply the x and y coordinate by 5. So your coordinate point is actually 5 radical 2 over 2 and 5 radical 2 over 2. And that's it. So you can base it off the unit circle. Just make sure you multiply by 5 in the end, and that'll be your answer. All right, last couple of questions here. Solve for x. Cotangent of x minus 30 equals tangent of 4x plus 10. Please, 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 tomorrow do not set them equal. The angles are not equal to each other. Tangent and cotangent are cofunctions and are equal when their angles are complementary. Cofunctions, complementary. So you're going to take these and you're going to sum them to 90. So you need to make sure you know that. Okay, so then this is just a solve from x from here. So 5x minus 20 equals 90, and yeah, you can solve from there. And then lastly, number 22, point A, which is 14, negative 48, lies on the terminal side of an angle theta in standard position. Find all 6 trigonometric functions. Okay, so let's actually draw a triangle here. If you were to plot the point 14, negative 48, it would end up in quadrant 4. Okay, so here's your right triangle. You went over 14 and down 48. Which means we're going to need to find this hypotenuse in order to do our trig functions. So Pythagorean theorem, which I'm just doing positive 48 squared because it'll be the same thing. Okay, so 250, 0, so 50, so that means this is 50, okay? This is basically just asking you to do SOHCAHTOA. Okay, so sine is opposite over hypotenuse, so negative 48, oopsies, negative 48 over 50. Cosine is adjacent over hypotenuse, so 14 over 50. Tangent is opposite over adjacent, so negative 48 over 14. That's that. So if you want the reciprocals, just make sure you pair them up correctly, like I'm doing. All you have to do is flip fractions. So negative 50 over 48, 50 over 14, and negative 14 over 48. And then you're done. Okay, so really this is just SOHCAHTOA. That's it. So just make sure you draw your triangle right, and then do SOHCAHTOA with it. But if you draw your triangle wrong, then you're going to be in trouble. And that's it. Okay, so that's just, 33 minutes worth of trigonometry. So, yay, enjoy. Or 30-some minutes, depending upon how much I edit out of this. Yikes. All right, bye.